Hello, today we're going to talk about mirror equation. So that's 1 over dO, so distance to the object, plus 1 over di, distance to the image, and then 1 over f. So this is focus length. So we're going to derive it. Okay, so we're going to use concave as an example, concave mirror. So this side is shining. This is the shining side. And this side is not shining. So this is called concave mirror. So if you think about it, this is like a cave, right? So this side is kind of like a cave. So it's called concave mirror. All right, so let's draw some lines here. The principal axis. And we have the focus. And then we have the center. Okay. And so we're going to draw the image here. I mean, object here. This is my object. So let's, the first ray we're going to draw is parallel to the principal. This is the principal. Okay. I'm just going to go through the focus. Okay. And this is called HO. And so if we do this, we're going to go, this one's going to go through the focus first. And then it's going to come out parallel to the principal axis. So you can see your image is going to be right here. So that's your IMG. And so this is your HI. So now let's look at some, let's see, HI. So we're going to look at this one here. This triangle. And what's the other triangle? So this triangle. Okay. So this are the same angle. If I have a ray comes here, and it's going to come out like this, and that's according to the reflection, law of reflection, that two angles are the same. So these two are congruent. So this one here, so let's call this one O, and call that one A, and call this one B, and call this one D, and then we can call this one, say, E. So DOA is congruent to BOE. BOE. Okay. So you have HO to the HI ratio. It's this is the DO. So DO goes from here to here. DO, this is the DO. DO. Right there. That's DO. And DI is right there. This is my DI. Okay, so HO to HI is DO to DI, right? DO to DI. So that's one. And another one, another pair that we're going to look at is the following. So we have this right here. So this is called F, right? And then you have this one here. So we're going to draw a triangle like that right there. Okay. So let's call this one H. Let's call that one P. Okay. P. So you have DFA is congruent to OFG. P. Okay, so those two triangles are congruent. So then you have HO to HI, right? So this side to this one here. This is also HI right there, right? It's equal to this one here is equal to AF to this FO there, to FO. Okay, so then AF is equal to DO minus minus F here, and FO is equal to F, right? So now we have everything we need. So this equation here, 1, and that equation 2 there, okay? So we have those two equations. Now we are ready to put them together. So let's do it. So I'm changing color to this one here. So then we have HO, right? So let's see, DO, okay, so we were here. So we are looking at equation 1 and 2, and we're looking at on the right side of this one here, DO over DI, and both left side are HO over HI, so they are the same. So we're going to equate the right hand side of the 1 to the right hand side of the 2. So then you have DO DI is equal to DO minus F divided by F, so like that. So now we're going to divide it by DO on both sides. So on the left hand side, if we divide by DO, the DO cancel out. So that becomes 1 over DI equal to, so the first term is going to be DO divided by F. So if you divide by DO, DO cancel out. So that only have 1 over F left. Here minus F and F cancel. So that become 1. So then we divide by DO, it just become 1 over DO. So then you put this term back to the left-hand side. Now you have DO, 1 over DO plus 1 over DI equal to 1 over F, which is the mirror equation. Okay, so that's the equation that we'll be using a lot, not just in mirror, but also in the lens. And so you should know how it was derived. All right, so we're going to stop there. Yeah. Bye-bye.